Welcome to the deep dive. Today we're pulling back the curtain on well, a silent technological revolution that is completely reshaping global commerce.
It really is. We are talking about smart ports, automated robot cranes.
And this promises, incredible efficiency. We're talking 247 operations, radically shorter turnaround times, and potentially billions in savings.
It's not that simple, is it?
No, not at all. This shift creates this really intense, almost existential drama. It pits that global trade efficiency directly against one of the most powerful, organized workforces in the world, the dock workers.
Right.
So our mission in this deep dive is to get at a critical question. Does this pursuit of pure AI-driven efficiency have to mean sacrificing human jobs?
And what are the hidden risks, the invisible cyber risks we create when we basically turn a port into a giant networked computer?
Exactly. And for you, our listener, who's constantly working with complex logistics data, we've synthesized reports on everything from global market forecasts and tech implementation all the way to
The high-stakes labor actions happening everywhere from Lisbon to Long Beach. And, the geopolitical cybersecurity concerns that are now front and center for coast guards globally.
Okay, let's unpack this, starting with the literal hardware and the software making these ports smart.
Well, the foundation of this whole revolution, funny enough, is just the simple, standardized shipping container.
Because it's uniform. It's the perfect object for automation.
It's perfect. And the tech stack really begins with the automated gantry cranes, or ARCs. They're the first thing people picture.
The giant machines you see from the highway, the ones that move containers off the ship.
Precisely. But they don't work alone. The sources really detail this whole interlocking ecosystem.
A stack of technology.
A whole stack. Once the ARC puts the container in the yard, you've got the automated stacking cranes, the ASCs.
And they handle the vertical storage. Like a giant game of Tetris.
A very efficient game of Tetris. And then connecting everything, moving containers between the ship and the stack. You have the AGVs.
The automated guided vehicles.
Right. Think of them as the port's own fleet of self-driving trucks, all powered by this integrated AI and machine learning.
So this is way past simple robotics. We're talking about a fully optimized thinking network. What are the immediate real-world returns that justify this massive overhaul?
So look at the Port of Rotterdam. It's a prime example. They use AI-driven predictive analytics for the whole logistics chain.
Not just for the vehicles.
No, for everything. Predicting when a vessel will arrive, managing traffic in the channel, optimizing the docking schedules. It just smooths out the whole operation.
And that efficiency has to tie into sustainability, right? Which is a huge issue for the big carriers.
It absolutely does. OOCL in Hong Kong, for instance, uses AI for fuel monitoring. The system can predict optimal operating conditions to cut fuel use and emissions. So it's not just about speed.
It's about hyper-efficient resource management.
Exactly.
And when you do look at the speed, the numbers are that they're just eye-opening. We're talking AI cranes moving containers 30 to 50% faster than traditional ones.
Which leads to just staggering throughput. The Port of Shanghai, which is the world's busiest, handles over 47 million TEUs a year.
TEUs being 20-foot equivalent units.
Right. And their automated terminal cut operational costs by 15% and boosted efficiency by 25%.
That dynamic is really changing what the machine itself even is. As the sources point out, a crane isn't just a fixed piece of hardware anymore.
What's fascinating here is AI shifts the whole paradigm. In the past, a crane had a fixed spec until you did a major physical overhaul years down the line.
Sure.
Now, the algorithms are continuously retrained on real-world data, weather, congestion, you name it. The crane's performance is no longer static. It's a dynamically optimized, constantly updating system.
Which creates a whole new kind of reliance on the software vendor.
A huge one.
And that continuous learning requires massive investment, which I guess brings us to the core economic reality. This isn't just about faster cranes.
No, it's about a competitive, multi-billion-dollar race to modernize. The investment commitment is it's clear.
What are the numbers?
The global automated container terminal market is valued at just over $10 billion this year.
In 2024.
Right. But it's forecast to soar to almost $18 billion by 2032. That's a compound annual growth rate of about 7.3%.
And if you isolate just the autonomous cranes segment, that growth is even faster.
It's an 18.6% CAGR. The main driver is, like you said, the need for higher throughput. Global trade volumes grew 2.4% just last year.
But the real financial engine behind it all is cost reduction.
It's always cost reduction. Automation fundamentally targets labor costs with promises of cuts up to 40%.
Let's go back to Shanghai's automated terminal. It cost, what, $2.15 billion to build?
An enormous sum. But the operators expect to save an astonishing $80,000 per vessel that calls there.
And we know exactly where that saving comes from.
We do.
A 70% reduction in the labor costs needed to run the terminal. That's the financial justification laid bare.
The equation is brutal. Invest billions now to secure decades of reduced labor spending.
Yet there's a major restraint here. Not every port can justify that kind of multi-billion-dollar capex.
No, especially not smaller or mid-tier ports. I mean, the studies show that to justify full automation, a port needs to hit productivity gains of 30% or cut operational expenses by about 25%.
So that's a high bar to clear, which explains the market breakdown we're seeing.
Precisely. Semi-automated terminals have the majority market share right now, about 66%.
Because it's a lower-risk, incremental path.
Exactly. You can upgrade key systems without needing a complete from-the-ground-up redesign.
Okay, here's where it gets really interesting. Because this pressure cooker isn't just about tech or finance. It's about the massive human element fighting back against those exact labor cost savings.
That's 70% reduction in Shanghai. That is a massive social risk.
And it's inherent in the design.
It is. These ARCs are designed to replace people doing repetitive tasks, which leads directly to these mass redundancy fears.
So the dock workers are demanding what they call a just transition.
That's the term. They're arguing that if their jobs are the ones being lost to create these huge corporate savings, they need to be involved in the solution.
And their demands are pretty specific. It's not just vague resistance.
Not at all. They want guaranteed retraining programs, generous early retirement packages, and, this is critical, a mechanism for profit sharing from the savings that automation creates.
We've already seen this conflict escalate, right back in 2023 in the U.S.
We did. The ILWU, the Longshoremen's Union, staged high-profile slowdowns at the massive ports of LA and Long Beach.
And their argument wasn't just no automation.
No, it was a demand for job security clauses, guarantees for their positions, or a pathway for a fair transition before more autonomous tech was rolled out.
That U.S. fight really set the stage, but this has gone global now, fast.
It has. The sources detail the formation of the Global Maritime Alliance, which was announced at a summit in Lisbon.
And this unites unions from over 60 countries.
Into a single, cohesive body. This is a fundamental shift in labor strategy. Their resolution from that summit calls for coordinated, immediate global strike actions
against any operator who implements this kind of job-killing automation without union consent.
And they're not just issuing warnings, they're laying out a clear catastrophic threat. They're preparing for coordinated global strikes.
Lasting 3 to 4 weeks.
Designed specifically to paralyze world supply chains, to force governments and corporations to the negotiating table.
So what's the counter-argument from the operators?
The operators argue that automation doesn't destroy jobs, it just shifts them to higher skilled roles.
Like remote monitoring, maintenance, that sort of thing.
Right. Technical engineering, software diagnostic.
But is that a realistic transition? I mean, for a workforce that has spent decades operating heavy machinery, is a sudden shift to software engineering a viable path for everyone?
Well, that's the key question, isn't it? The whole strategy relies on a massive, successful investment in retraining. The goal, from their perspective, is to move workers from the hazardous dockside into safe, climate-controlled, remote monitoring centers.
So the job becomes supervising the software, not driving the machine.
That's the idea.
Okay, speaking of the hazardous dockside, let's pivot to this final tension point. Physical safety improvements versus digital security risks. Automation has to be an unqualified win for physical safety.
Oh, absolutely. A huge benefit. It fundamentally removes humans from one of the most hazardous industrial environments.
And the ARCs has sophisticated sensors, right? Object detection, LiDAR.
All of it. Sensor fusion to reliably tell the difference between a person and a container, to prevent collisions, to ensure safety protocols are followed automatically, tirelessly.
And we have hard data on this. The case study from Kwai Chung Port in Hong Kong.
Right. After they adopted an AI safety package, they saw a reported 60% drop in fatigue-linked human errors.
And a 10-fold improvement in lift zone safety.
Because the AI is a tireless auditor. It never gets tired, it never looks away.
But that same connectivity, that digital brain controlling the physical machine, that opens up a huge security risk.
A severe one. This is where we see the convergence of IT, your corporate email, and OT, the operational technology that actually controls the cranes.
And all the sensors connecting them, the industrial Internet of Things.
Exactly. When those systems merge, a massive piece of physical equipment, the crane itself, essentially becomes one giant network-connected
A
computer.
massive target.
A massive target. And this is not a theoretical vulnerability. The sources point to some really alarming finding from the U.S. Coast Guard.
About the security of cranes made by ZPMC, Shanghai Zhenhua Heavy Industries.
Yes, and their market dominance is staggering. They account for over 80% of the ship-to-shore cranes in the U.S.
80%. So what did the Coast Guard find that made them call this a silent threat?
Several critical vulnerabilities. Improper network segmentation was a big one.
Meaning an attacker could easily jump from the regular IT network over to the OT network controlling the machinery.
Correct. They also found the continued use of old, insecure protocols like Telnet. And maybe most troubling, embedded cellular modems that could potentially provide an unauthorized remote backdoor into the crane's systems.
So the threat here isn't just about stealing data, it's about someone potentially taking control of the physical crane.
Precisely. Compromising the OT systems could cause massive disruption, halting a port, crippling container flow, and pose a direct physical safety risk. Cybersecurity here is about preventing a physical catastrophe.
So what's the advanced defense against a threat that's sophisticated?
Well, beyond stringent standards and better network design, the really innovative solution being deployed is digital twin technology,
Creating a virtual replica of the entire port.
a high-fidelity virtual replica. These sandboxed environments let them simulate operations, predict failures, and crucially test and practice their response to a cyber-physical attack without ever risking the actual infrastructure.
So if we synthesize everything we've looked at, the market is betting billions on automation, driven by these undeniable efficiencies.
It feels like an inevitable trend for any port that wants to stay competitive.
But that push for faster, cheaper logistics is clashing directly with this organized global demand for economic justice from the workforce.
And that threatens coordinated action that could paralyze the very supply chains automation is meant to streamline.
And running underneath all of it is this fundamental and maybe unaddressed cyber risk linked to the global dominance of certain foreign manufacturers.
You know, the sources really highlight that while reducing lead times is great, what matters most to the supply chain, and especially to a logistics professional like you, is the reliability of those lead times, stability.
Right. If a major labor strike or a cyber attack can cause weeks of chaos, those short-term efficiency gains are completely wiped out.
Which brings us to a final provocative thought for you to chew on. We've shown how the future of container handling depends on integrating hardware, software, and these high-stakes labor agreements. So, given that both the labor negotiations through the Global Maritime Alliance and the core operational technology like the ZPMC cranes are increasingly tied to global alliances and foreign manufacturing, how does a port truly define and secure its operational sovereignty in this hyper-connected, hyper-conflicted world?
A truly high-stakes question. Thank you for diving deep with us today. We'll see you next time.